So for this conditional probability, we have two dice being rolled, and they're distinguishable, which so a red and a green one. Right? So we have two events. Event A, that the red die, the Q04. Then B is the event that the sum of the two dice is equal to 6. And then we want to find the conditional probability of B given A. So we know A has happened, that A has happened, and that B, so what the probability B is. So one way to do this is to take, again, probability is all about counting. When we do a conditional, we change what we're counting. We change the way in which we're counting. So we know A happened. So A, we know that the red die is showing a 2 or a 4. Circles aren't always great, but here's A's happening. And then we're going to consider the probability of B happening. And now the place where is this overlap, right? A intersect B, that's what this is going to lead us to, is we want this area in comparison to what's in A, because we know A happened. So A is the total of things that have happened, is the red circle. That's the universe now. B has not happened, doesn't matter here. So let's see if we can fill this in. So A is we got a 2 or a 4. So we could have rolled a 2 and a 1. That would not give us a 6, right? And we'll just, my ordered pair is that the first number will be the red die, the second would be the green. We could have gotten a 4 and a 1. So a lot of different things we could have gotten that would give us an A, the first dice being rolled. But what are the things that would cause B to happen? Well, if we rolled a 2, what would we need to get? We would need to get a 4. So that gives us 6, because B is getting a 6. 6 multiple ways for it to happen, but we don't have to list it. If the red die were a 4, then we would need a 2, because 4 plus 2, the green die would need to be 2. Okay. So that's what's in the intersection. There's two things in the intersection. Now we got to figure what all is in A. What all is in A. We could go through and count each thing that has a red die of 2 or 4. And we'll just do this as the red over here. We've got 1, 2, 3, 4, 5, 6. Just going to do this out. And then we know that if the red die is 2, what are all the different options? The green could be a 1, a 2. It's the green. A 3, a 4, a 5, or a 6. So there's 1, 2, 3, 4, 5, 6 different options. If we roll the 2, one of them's counted here, the 2 and the 4. So that means there's, put that there is 5 options of getting a 2 that doesn't add to 6. How about with a 4? So we could get all of these options, right? A 1, a 2, a 3, 4, 5. Only the 4 with the 2, so this option here, I guess I should circle them, and this option here give us a total of 6. So then there's 5 other options of rolling the 4 that are here. So that's a total of 10 here, 2 here. So the total in A is 12, right? 6 and 6. Total in A. Number in A, and then we'll look in the number in A intersect B. If we think back to it, that's what the probability of B given A is equal. So we can go back to that formula, and that's what we did by our counting. So we've got 2 divided by 12, which is 1/6. And they want us to express it as a fraction, so we did. It's nice right there. And there it is, 1/6.